6.2 Right Triangle Word Problems. So this lesson is an application of what you've learned in 6.1, the basic trig ratios. So first we have an angle of elevation. An angle between a horizontal line and a line of sight where the angle is above the horizontal line. So you have an angle of elevation, and then you have an angle of depression, which is the angle between a horizontal line and a line of sight where the angle is below the horizontal line. So if you look at the diagram to the left, you'll see the angle of elevation, your horizontal line. The angle is above the horizontal line. Angle of depression, you see the horizontal line and the angle is below it. Couple of things to notice. The two horizontal lines are parallel. And the angle of elevation and depression are congruent. Angles that do this are called alternate interior angles. And if you draw a line, then a right angle is formed. And this line needs to be vertical. So given the few examples, the right triangle word problems deal with angles of elevation and depression. So we want to use those couple concepts to solve these few problems. So the first problem says a palm tree casts a shadow of 18 feet long. The angle of elevation of the sun is 26 degrees. Find the height of the palm tree. So a palm tree has cast a shadow of 18 feet. So just looking at this diagram, we can say that this is going to be our 18 feet. Because that's the shadow. The angle of elevation of the sun is 26 degrees. So remember your definition for angle of elevation. It's the angle that is above the horizontal line. So my angle of elevation would be here, which is 26 degrees. So using that idea, I can now use my basic trig ratios to find the measure or the height of the palm tree. So I have, this is what side I'm looking for. So the x is going to be my opposite and the 18 is my adjacent. So that would be tangent of 26 equals x over 18. Multiply both sides by 18. And x equals 8.779 feet. And that's the height of the palm tree. The next example says a sign on a roadway at the bottom of a mountain road indicates that the road will incline 10.5 degrees with the ground. Find the altitude for a car ascending up the mountain road. The altitude for a car ascending up the road is 3,850 feet. Find the length of the mountain road in miles. So the altitude is just going to be this vertical line. That's 3,850. And we want to find the length of the mountain road. So we are looking for this value. And we can see that x value is our hypotenuse. So we have opposite and hypotenuse. So the sine of 10.5 equals 3,850 over x. So again, when we're solving for a variable in the denominator, we switch it with the other side of the equal sign. So x equals 3,850 divided by the sine of 10.5. And type that in our calculator, we get 21,126.506. Now this measurement is in feet, but our answer told us to put it in miles. There are 5,280 feet in a mile, so we'll do that conversion. And so the answer is 4.001 miles. Next example. The sonar of a Navy cruiser detects a submarine that is 4,000 feet from the cruiser. The angle between the waterline and the submarine is 40 degrees. Is 34 degrees. How deep is the submarine? So what we want to look at here, we need to know how deep the submarine is. So we're trying to find that value. The Navy cruiser detects a submarine that is 4,000 feet from the cruiser. So that's going to be 4,000. And so now we just need to see what the angle that we're looking at. Well, it says the angle between the water line and the submarine. So here's the water line and the submarine, so it's going to be this angle, which is 34 degrees. So that gives me an opposite side and a hypotenuse. So it's going to be sine of 34 equals x over 4,000. So multiply 4,000 on both sides. 4,000 sine of 34. X equals 2,236.772 feet. That's how deep the submarine is. So we'll move on to the next example. Remember to make sure that your calculator is in degree mode when you're doing these problems, so that your answers don't come out wrong. Next problem, a 20-foot ladder leans against a house and the base of the ladder is 5 feet from the base of the house. What is the angle formed by the ladder and the ground? So this is the angle that we're looking for, because that's the angle formed with the ladder and the ground. The ladder is 20 feet and the base is 5 feet from the house. So since we're solving for an angle measurement, we're going to be using our inverse trig values. So we have the adjacent side and the hypotenuse. So we set it up, the cosine of theta equals 5 over 20. So to find out what theta is, we take the cosine inverse of 5 over 20. And that gives us theta equals 75.522 degrees. Next example, from a point on the ground 500 feet from the base of the building, it is observed that the angle of elevation to the top of the building is 24 degrees, and the angle of elevation to the top of the flagpole atop of the building is 27 degrees. Find the height of the flagpole. So I'm looking for that value x there. Well, the distance, a point on the ground 500 feet from the base of the building, so this is 500 feet. The angle of elevation to the top of the building is 24 degrees. So this is 24 degrees. To the top of the flagpole is 27 degrees. So I'm going to find K, then I'm going to find H, because K minus H will give me X. So if I'm just looking for K, that's just going to be that opposite side there, and it's the opposite side of angle 27. So tangent of 27 equals K over 500. And then we have, for H, we have tangent of 24 equals H over 500. So we're solving for two of those. Multiply 500 on both sides. So 500 tangent of 27, K equals 254.763, and 500 tangent of 24, H equals 222.614. So if I subtract those two, I get X equals 32.148 feet, and that's the height of my flagpole. All right, our final example says find the height of the building. Now this example will require a little bit more work. It's a little lengthy. So I'm trying to find that height X. Well, I need to know the total distance from point A to the bottom of the building, but I don't have it. All I have is the distance from point A to B. So I'm going to need this value. I'm going to call it Y, because I need to know the whole distance, because I need to know the whole base of that triangle. So I'm going to set up my trig ratios with the given information that I do have. So I will say the tangent of 30.2 equals X over Y, because that's opposite over adjacent. Well, the tangent of 24.1 equals the opposite X over 600 plus Y, because that's the whole base of that triangle. Notice that you have to take into account that there are two separate triangles here that we're working with. And you need to make sure you account for both of them. Well, now that we have these two things set up, we need to solve for one of the variables. And the one that we can solve for quickly and easily is going to be that that y variable. So we're going to multiply both sides by y, and this one times 600 plus y. So now we have y tangent 30.2 equals x. And the other one says 600 plus y times tangent 24.1 equals x. So now that they both equal x, I can set them equal to each other. So y tangent 30.2 equals 600 plus y tangent 24.1. So what you want to do here is distribute the tangent of 24.1. All right, once you've done that, we're going to move everything with a y on one side. So y tangent 30.2 minus y tangent 24.1 equals 600 tangent of 24.1. Now we'll factor out the y. So you have tangent 30.2 minus tangent 24.1 times y equals 600 tangent of 24.1. So we'll divide by all of that. And that will give me y. So I'll type that in. Remember to use the fraction bar in your calculator, or you may be using Desmos. Either way, make sure you put it in correctly so that it does the correct order of operations. And remember to close your parentheses after you do the tangent function. So y equals 1992.1.638. So now I need to find out what x is. Well, x is given as y times the tangent of 30.2. So 1992.638 times tangent of 30.2. And that gives me the height of the building is 1159.743. So this is your final answer. Remember to set up the ratio with the two triangles, your tangent opposite over adjacent, and then solve for one of the variables and set them equal to each other and just distribute and solve at that point. This is actually similar to what we did when we did inverses of rational functions. Notice that these first 6 problems also were given each diagram. Remember that we don't round to the 10th place, we round to the thousandths, 3 decimal places. Also, they had diagrams. Now the next section tells you to draw a diagram. It is important that you draw a diagram so that you know what you're doing when you try to solve these problems. So we're going to draw some quick diagrams and solve these last few problems. Okay, so a skateboard ramp at a park has an inclination of 48 degrees and its base is 14 feet long. What is the length of the ramp? So we have a ramp. We know it forms a right triangle. So the inclination is 48 degrees. The base is 14 feet long. How long is the ramp? So we're looking for the hypotenuse. So that would give us the cosine of 48 because it's the adjacent and the hypotenuse equals 14 over x. So x equals 14 over cosine of 48. And x equals 20.923 feet. Draw a diagram. It's very important that you draw a diagram. All right, you're 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. What is the angle between this path and the river's edge? So you have this river, and you're standing over here. You're going to walk 400 yards to the river's edge instead of walking in a straight line. You want to know the angle between this path and the river's edge, so that's theta. And you are 200 yards from the river. So that angle is given as the opposite and the hypotenuse. So we would set it up as the sine of theta equals 200 over 400. So theta equals the sine inverse of 200 over 400. Type that in the calculator, and theta equals 30 degrees. Example C, a 5'9" inch person is 12 feet from a tree. The person is looking at the top of the tree with an angle of elevation of 62 degrees. How tall is the tree? So we have a person. They're 5'9". They're looking at the top of a tree. In their line of sight. The angle that they're looking at is 62 degrees. So what we want to know is how tall is the actual tree. So we want to find this value, x. Well, we know this is 5'9", which is actually 69 inches. So we just need to find the remaining height of the tree. And we're 12 feet from the tree, so 12 feet would be 144 inches. So we have the opposite and the adjacent, so tangent of 62 equals x over 144, multiplied by 144. It's 270.825 inches equals x. So we're going to add the remaining 69 inches, and we'll change it back to feet. So that's 28.319 feet, or 339.825 inches. Next, a water tower is located 325 feet from a building. From a window in the building, it is observed that the angle of elevation to the top of the tower is 39 degrees, and the angle of depression to the bottom of the tower is 25 degrees. How tall is the tower? So here's your building and the window, and then you have your water tower. So to the top of that, remember your line of sight, your horizontal line, to the top is 39 degrees. To the bottom, 25 degrees. Remember, they're 325 feet apart. And you want to know how tall this tower is. So you're going to find x, and you're going to find y, and x plus y equals the height of the tower. So that means we have x over 325. That's opposite over adjacent. So tangent of 39 equals x over 325. And tangent of 25 equals y over 325. So multiply by 325 on both sides. So 325 tangent of 39 is 263.180, and 325 tangent of 25 is 151.550. We'll add those two together, and our height is 414.73 feet. And the next example, E. A plane is flying 5,200 feet above the ocean and sees two ships that are traveling in front of one another. The plane's angle of depression to the furthest ship is 46 degrees. The plane's angle of depression to the closest ship is 52 degrees. How far apart are the two ships? So here's my plane. Here's ship 1 and ship 2. We'll call them A and B. And we'll call this P for the plane. All right, so our horizontal line of sight. Remember, the angle of depression to the furthest ship, which is A, is going to be 46 degrees. The angle of depression to the closest ship, which is B, is 52 degrees. So what does that mean for this setting? That means this is 46 degrees, and this is 52 degrees. because they're alternate interior angles and they are congruent. So we want to find the distance between the two ships. So we're looking for this value x here between A and B. Well, eventually we have to find y before we can find A and B. And we know that this is 5,200 because that's how far the plane is above the ocean. So we're going to find this value first, and we'll call this z, the total value. So that means the tangent 46 equals opposite 5,200 over z. So z equals 5,200 over tangent of 46. So z equals 5,021.582. So now we're going to find y. So we have the tangent of 52 equals 5,200 over y. So y equals 5,200 over tangent of 52. And y equals 4,062.685. So we'll take z and subtract y from it. Because x equals z minus y. So x equals 958.897. And that's my answer for that one. Now, we have one more problem, and it's your critical thinking problem. Complete the word problem below. It will require multiple steps. Shown in the figure is part of a design of a water slide. Find the total length of the slide to the nearest foot. So we have to find this value, and this value. So we have multiple right triangles inside this object. So we're going to use that idea to find the information we need. Well, we know from the diagram that that's 15, and this is 15. So we can find those measurements we can find those hypotenuse for here. We can find the hypotenuse for here. And then we can find this part, and we can find this part, so that we can find out the total length of the middle section. All right, so let's begin working on this problem. So first we're going to find A. So we have 15 in A, so that's opposite and hypotenuse, so that's sine of 35 equals 15 over A. Well, A equals 15 over the sine of 35. And so A equals 26.152. Let's find B. So again, it's going to be sine of 25 equals 15 over B. So B equals 15 over sine of 25. So B equals 35.493. So now we need to find sides C and D. Well, you can do this two ways. You can use Pythagorean theorem, or you can use a trig. For the sake of time, we're going to use the Pythagorean theorem on one and the trig on the other, just to show both cases. So we'll find C first. So that means we'll use Pythagorean theorem to do this one. So we have 15 squared plus C squared equals 35.493 squared. So C squared equals 1,034.753. Take the square root of that, and C equals 32.168. So I've got A, I've got B, I've got C. Now let's find D. So we'll use trig to find out what D is. So that means the tangent of 35 equals 15 over D. So D equals 15 over tangent 35. So D equals 21.422. Now you might ask, why did I find D? Because I know A and B, but I don't know this middle section here, and I'll call this E. Well, the whole thing from here to here is 100. So 100 minus C minus D will give me that E part, that middle part that I need to find the length of the actual water slide. So that's why it was important for me to find C and D. So 100 minus 32.168 minus 21.422 gives me E, which is 46.41. Now that I have those three parts, I have B, A, and E, I can add them together, and it gives me the total length of the water slide. And given that I have all three of those, 26.152 plus 35.493 plus 46.41, I get 108.055 feet. And that is the length of my water slide. So that's the conclusion of 6.2, the right triangle word problems. I'm going to actually assign some problems through Delta Math for you guys to work on for 6.1 and 6.2. So please pay attention to what you're doing throughout these lecture notes. Make sure you know how to use your trig. Your opposite over hypotenuse is sine, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You will not use the other three for these word problems. You will not use cosecant, secant, and cotangent, only the first three, the main three. And so that is the conclusion of 6.2.